I've been going through this blog of doing asymmetric encryption using Java, the JCA Java Cryptography Architecture. I came around a very nice idea of using Pyjnius to actually access these Java classes, actually make a customized API for generating the private and public keys in Java and then return to Python. So I can actually bridge this JCA architecture with Java, and we will not be needing the cryptography or PyCryptodome libraries on Android if we just use the inbuilt JCA for the encryption part. So let me just start with creating a, oh sorry, this needs to be a folder. I'm just creating a simple package first so I can just access. Yes, now I will create a class with the name encryptor. Yes, now just define the package. Now, as you go down reading the blog, you will know how you can generate the keys, the public key and private key used for asymmetric encryption. So let me first tell you about what happens in asymmetric encryption. First of all, two keys are generated using the key pair generator. What it does, it creates unique keys for encrypting and decrypting, and these keys are generated only once. So this is a one-way process. Once you encrypt using the public key, you can only decrypt the data with the private key that is being generated at that instant. So this is what happens in asymmetric encryption. Once you encrypt with the public key, it is of no use. You need to have the private key generated at that instant, or your data is encrypted forever. So what we are going to do is to first generate two keys for ourselves, and we need to have some modules from java.util.arrays, and these are for personal use because I want to return a array list back to Python, so I can just use it as a normal list and get the private and public key. Let's get here and see what we need for this. We need the key pair from and key pair generator. Okay, and yeah, let's see what more things we need to. Yes, we will need to import cipher later for encrypting and all this. So these are the things we need to have right now. Let's just copy them. So java.security.keep. So they are not being used right now, so that's why it's showing in yellow. Now I'm gonna create a public class encryptor, the same name as been provided, and a method. What it will return, it should return a list of bytes later, but let's just keep it as void because we don't want any errors. Predicted public void generate RSA. I'm gonna name it as generate RSA key pair, and it will gonna require the key size. I'm gonna get the key size also. Let me import the, let's leave it that, we can do this later also. Now I'm gonna create a tag. Private static final string. Now I'm just gonna create an algorithm variable first. Algorithm is equals to RSA. Now this, whenever we want to change this to something else, you can just change it here, but I'm just gonna put this as like this right now. Let's make it here, and now what we're gonna need is to create a first we need to create a key pair generator. So key pair generator, yes, this naming is the best. New let's see what's given here. Dot get instance, yes, not a new class, but to get an instance of this, and the algorithm we wanna pass. So this is the algorithm. The algorithm is RSA. Now we get a key pair generator. Now we need a key pair. So the second thing is to get a key pair. Key pair generator dot generate key pair, and the key size would be 20. Let me see, it should have been a we need to first initialize. That's why I was confused. First we need to initialize with the key size we want. So the current day standard is to use 2048 bits. We need to use minimum 512 bits, but I am using 2048 here, so that should not be a problem. Let's Yes, now it is initialized. Now we wanna create a key pair equals to yes. So now we have our key generated here. Also, what we can do is to use new secure random, the second signature of this initialize function. Now what it does, it provides this as a salt for the key. So whenever we generate a new key, it's unique, not similar to the previous one, not so provided. The next is to get the public key and the private key. So let's now here I'm gonna use Python for getting the keys from Java. Now the Python except for this I'm gonna get a simple list in Python like this, two variables public comma private, which would be assigned the values. So for this I think we should use arrays dot as list to return the values. So what we can do is return arrays dot as list, and here we can provide a key pair dot get public dot get encoded. Second thing will be key pair dot get private dot get encoded. Yes, so this will return the list. Now what is the error? So yes, now this needs to be something like this, list of byte arrays, because this is a byte array, this returns a byte array, and the semicolon. Let's also create a now this is used, and now let's get to the another function. What we want to do is to encrypt the data. So this would be named as encrypt, simple encrypt with the data we want. So we want to create a byte data, and in this we will create a cipher object. We'll get a cipher instance to encrypt the data. We'll get back to this later. Currently I'm just gonna comment this out because we don't need this right now, and these two also. Okay, let's first compile this. Let's see if it's actually compiling or is there any failure. Java C crypto.java. Shit. Yes. Okay, so we got the encryptor.class. Now let's come to Python and import Genius. From Genius import auto class. Now create a reference to the encryptor class. com.nofensec.python.encryptor. Yes, now let's see if we can generate keys. Public comma with equals to encryptor dot generate RSA key pair. Let's see if we can get this working, and open this in terminal. Okay, cannot constant with none or class none. Okay, so this is occurring because we haven't defined the static method. Because if this is not static, then we need to create an instance for the class, but now this is static, so this should work. Let's just compile it again. Yeah, and I'm gonna compile this again and run this. Now it should run. Yes, now it is running, and we can also print the X of the private and public keys. Then the private key. Let's print the X of the keys. Yes, so this is the hex for the generated keys. Now we got the public key, and we are getting the public key and the private key, and we saved it in two variables. The next goal is to encrypt some data in any file. Let's create a test.txt file and write something in this. This is encrypted. Okay, now we want to encrypt this data with the public key and then decrypt this data with a private key. Now, first of all, we need to read the contents of this in byte format, and I'm going to pass these byte to the function encrypt for the encryption part. Now let's first open the file with open test.txt, and it would be read byte mode as data file. Then we're gonna read the content of the file to data file dot read. Yes, this would be the content of the file. Or we can also yes. Now let us save the public keys and private keys also to some JSON file. Let's import JSON and save these keys to some JSON file so it can also read and write at the same time. And I'm going to move this to a function called generate keys. And this would contain a public comma private. Now let's create a function encrypt data. And then we want to first read the data from this file. And we are going let's create these as public comma private as global variables bytes. And access it here to make changes. Okay, so now everything is set. Now we will call this generate keys function only and only if we do not find the keys.json file or any kind of data in it. So we are gonna with if os path, we haven't import os, and we are gonna check the path if it exists os.path.join. Let's create a root variable. So this will get the directory of this file main.py, and then we can do additions to it, root comma, and the name of the file would be keys.json. Yes, if os.path exists. If it does not exist, then what it should do, it should generate keys, and generate keys should also save these keys to the file. So with open keys.json would be read mode, encoding would be UTF-8 as a key file, and but it we are gonna write to it, so it should be write mode, key file dot write json dot dumps. Now we pass here a dictionary object with the first one as public, and we are saving bytes public dot hex. So this would store a string of hex letters, so it won't it would be easier for us to load it. And bytes private hex, I'm gonna save the hex of these, not direct bytes. Now this should write to the keys.json in the form of dict. This would convert to a JavaScript dict, JSON dict, and would be saved to the keys.json file. And here we are gonna see if keys.json exists, and if it does not exist, we will generate the keys. The next is to read the keys from these files. So copy this same and with open keys.json as R. JSON.loads. This would be simply JSON.loads. And key file dot read. Now public comma private would be, for encryption we only need the public key, so I'm going to just do public bytes dot from hex, because we stored the hex, now we convert to bytes. Content, and the key is public, so we get the public key in the public variable stored. And let's get the global variable also. Yes, now it should do. Now what will it do? It will open the test.txt file and read the content of this. Now this also needs to be defined somewhere. It's content. So now this is the content, and we read the content. Now we pass this content to the encryptor. Encrypt public encrypted data equals to encrypted data would be equals to this, and then we will write back this encrypted data to some other file, so we can make record of something. Let's say text1.txt, and this would be write binary mode, and we will write we can also write the hex of this, but let's simply write data file dot write yes, and let's implement the encrypt function now. In this we are going to get the plain data in the bytes, in a byte format, and the byte array of the public key. Public key. Yes, now this is a byte, not this. Yeah. Now first of all we need to generate the public key again from the bytes of the public key. So we're going to need the key factory for that specific algorithm. Import java.security key factory and import spec.x509 encoded key spec for the public key, security.spec.pkcs8 encoded key spec for decoding private key. Now create a new key factory instance, key factory to key factory dot get instance algorithm, then pub spec now x509 encoded key spec is public spec is equals to a new x509 encoded key spec and the public key bytes. So these are bytes, public key bytes. Now next is the public key. Public key would be equals to key factory dot generate public pub spec. There are two signatures, I think. Yes, this one, pub spec. Now we got the public key, and using this we need to encrypt the data. Now we need a cipher instance. Cipher for equals to cipher dot get instance padding. Now we have already defined the padding as RSA EC PKCS1 padding. In the blog it gave no padding, but I am using a PKCS1. Let's add this so it doesn't give any kind of exception. Now these are not being used. Now what we are going to do is cipher dot initialize for init and cipher.encrypt mode, and key would be public key simply. Now we are gonna return the bytes of the cipher.doFinal cipher. Now this would finally encrypt the data, and it requires one thing, that is the plain data. This is the signature for that, and everything is done right. Now let's see what's the error. Now the error says it returns void, but it's actually returning a byte array. So we are going to set this like this, and everything is solved. Encrypt mode. Oh, now this is the whole function for encrypting the data. Same would be a decryption, but instead we will use a PKCS08 spec. Now let's create a function like this too, and it would be same as this. We create a copy and just make some adjustment. Now public byte decrypt. This would be decrypt plain data and private key bytes. Key factory looking algorithm. Now this will be PKCS8. Private key bytes, and this would also be PKCS8. PKCS8 encoded key spec for private key bytes and private spec. Now this would be private key, and this would also be private key. Cipher.get instance. Now generate, this should be generate private, and the padding cipher.in cipher.decrypt mode. The private key. This data is not plain, this is encrypted. So we're gonna change this simply so it feels it's different. Now this is the full Java API to encrypt and decrypt using the RSA algorithms, asymmetric encryption. Let's compile this. Java C com/Python /.java, and this is encryptor. So the compilation has no errors, so I think this is perfect. Now we come back to this main.py and continue from where we left. Now we can encrypt the data using the content and the public key. Since we are reading in the read binary mode, this returns a byte into content and we pass the same. Let's define content as also bytes. Yes, encrypted data encrypted .encrypt. Then we write in the write binary mode, and this is also for this keys equals to json.load and keys, so it doesn't interfere with each other. Now let's first try running the main.py and see if that saves too. Key.json. No, I think it should be generated. No, keys.json is not. Oh, we are not calling encrypt data for anywhere. Let's call this function encrypt data. Yes. Okay, we got an error. Method none. Okay, we have not defined static again. Let's see somewhere. Public static. Yes, public is static. This should be static, otherwise we need to create a class instance in Python also. And let's compile again. Yes, now Python. Yes, now it generated keys.json. Yes, and it is saving the hex of the private and public keys. Now we can also see text1 file. The bytes of the encrypted data has been stored here. We can also store hex to make it look better. Let's see, we can do something. Test1.write binary. Instead of write binary, we're gonna write as bytes encrypted data.hex, so it doesn't feel awkward. Let's see test1. Yes, now it is writing the hex of the bytes. The next thing is we want to do the decryption part, and let's define the function def decrypt. data. And we're gonna get the global, public, private, and first thing we wanna do is to read the private key. And for this function, I think the keys.json should be present by itself. If it's not, then the data should be lost. Now this variable here should point to private this time, because we need the private key. Yes, now we already read the private key from the keys.json file. Now we read the data of the encrypted file. This time the red should, since we are saving in hex format, the red should be as normal with encoding UTF-8. Since we saved the hex, it should be bytes.fromx. It should return the bytes since we are writing in the hex format. And the file is test1.txt. And let's write also in with the encoding, so there are no encoding issues. UTF-8. Now we read the contents of the data file test1.txt into content, and we wanna decrypt this data. So decrypted data equals to encryptor dot decrypt content comma private. Okay, so this will decrypt the data and return this in bytes format. And then we are going to write this again to another file in binary mode. Now this would be test2 in write binary mode, and binary takes no encoding. File write decrypt. We are directly gonna write decrypted data. So now first we encrypt the data and then decrypt the data, and this should work. Okay, a byte log object is required, not genius.byte array. Okay, so we need to do something like this. Now let's see. Yes, this is encrypted. Test1 is the hex, and test2 is the decrypted file, again with the same text. Now let's write something else, something absurd, and try again. Since it already got the keys.json, it will just use those for decryption and encryption. If we delete the files, it will first generate the keys.json and then write the data. So this is how we encrypt data using JCA in Pyjnius. And thank you for watching the video. If you like the video, please like, subscribe. Thank you.